Morning, guys. Firstly, happy New Year to you guys. Okay, it's another time to get serious. We're approaching the UTM exams. Very soon you'll be writing your UTM exams. So today we are working on the question of motion under free fall, and this is a very important topic in your jam when it comes to calculations. Equations of motion under free fall. Now, when I'm talking about, we did yes, one of our classes, one of our tutorials, we already explained equations of motion. We taught equations of motion. Okay, so now we are treating equations of motion under free fall. Now, when we do free fall, what do we mean by free fall? When we say free fall, now free fall is when objects fall under the influence of gravity. Now, when objects fall under the influence of gravity, that's free fall. So now there is the force of gravity, which we also call gravitational force, is represented by when objects fall under the influence of gravity, is what called free fall. Okay, so I said gravitational force is represented by G, which most of you know. And then the value of our gravitational force is most time 10 meter per second square or 9.8 meter per second square. This is the value of our acceleration due to gravity. Now, acceleration due to gravity is the force, or force of gravity is the force which the Earth attracts bodies to itself. Is the force in which Earth attracts body to itself. So now that's why when you throw something up, when you throw an object up, the force that the Earth attracts, that it used to attract the body to itself, pulls the object back to the floor. So that's what's called free fall. So after the object goes up, when the force of gravity is able to nullify the velocity with which you throw the object, then the object is going to fall. So that's simply free fall. Now, I said the value of acceleration due to gravity is 10 meter per second square or 9.8 meter per second square. So now let's say, for instance, I'm throwing an object from the top of a tower downwards. Like I'm throwing an object from the top of a tower downwards. Now you can see the object is falling downwards. Now the acceleration due to gravity, which is G, is going to be plus. That's positive. Why is because the acceleration, okay, let me draw something like this. Okay, so I have something like this. This is the acceleration due to gravity. It's acting downwards, pulling the object to the earth towards itself. The earth is pulling the object towards itself. And then I'm releasing, let me say, a stone from a tower. So the acceleration due to gravity is moving in direction. Oh, sorry, the object is moving in direction of the acceleration due to gravity, which means this is going to be plus G. But then if I'm throwing an object upwards, that's I'm throwing it from the ground upwards, the acceleration due to gravity is not going to be negative. Why? Because the object is moving in the opposite direction as the acceleration due to gravity, as the force of gravity is moving opposite direction. So it's going to be minus G. Now, this is it. When an object is moving downwards, its direction is it is in same direction with the force of gravity. So then the acceleration due to gravity will be positive. But then when it's moving in opposite direction, the force of gravity, that's when it's moving upwards, the acceleration due to gravity is going to be negative. Now, what we are dealing with is equations of motion under free fall. There are three equations of motion. One is E is equals to U plus ET. The other one is S is equals to UT plus half AT square. And then the third one is V square equals to U square plus 2AS. Now, these are the three equations of motion. I showed you guys how to derive it in one of our tutorials, how to derive these three equations of motion. So you can just go to tpaths channel on YouTube and then watch the tutorial. And if you were in the class you've forgotten, you can just go back and memorize it to refresh your memory. Okay, so this is it. These are the three equations of motion we have. Now, for this first equation of motion, now if the object is falling downwards, remember I said the acceleration due to gravity is going to be positive. So now acceleration due to gravity, I'm going to replace my G with this. So I have V is equals to U plus GT. That's replacing my acceleration with the acceleration due to gravity. That's the force of gravity acting on the object. Now, when I have S is equals to UT plus half AT square, this will become S is equals to UT plus half GT square. Don't forget, I said this is when the object is falling downwards. The acceleration due to gravity is positive. That's why I have this. Now, here I have V square is equals to U square plus 2GS. So I have this as my equation of motion under free fall. That's when the object is falling downwards. So I'll say when the object is falling downwards. So this will be my three equations of motion. I'm using G instead of A. So now this G is 10 meter per second square or 9.8 meter per second square, as the case may be. Now, when the object is upwards, that's when the object is moving upwards, I said my G will be minus, right? So this will give me V is equals to U. Instead of having this plus A, I'm replacing this A with minus G. So this will become minus GT, right? So then this will become S is equals to UT minus half GT square. Why? Is because I'm replacing this A with minus G because the object is moving upwards. And for the last one, I'll have V square equals to U square minus 2GS. And that's it. Simple. When it's moving downwards, V plus GT, you have your G as plus. And then when it's moving upwards, you have your A as minus G. G is positive, G is negative. That's downwards and upwards. And that's it. That's equations of motion under free fall. Okay, so let's move to some working examples. Let's do some working examples. Uh, this example one is from UTME question 1, 2017. It says calculate the time taken for a mango fruit that falls from a tree 20 meters to the ground. So the thing is, the height of the tree, the question says calculate the time taken for a mango fruit that falls from the tree 20 meters to the ground. The height of the tree is 20 meters. So that's the first thing I'll do. 20 meters is the height of the tree. And then it says calculate the time taken for the mango tree to fall, or the mango fruit, sorry, to fall to the ground. Okay, now, so the mango fruit is from an height 20 meters. So I write my S as 20 meters. I said I should calculate the time, that's T. I don't know what it is. Then my G is 10 meters per second square, as given me in the question. The question says take G as 10 meters per second square. So now I want to find the value of my T, which is time taken. Which of these can I use? Now, don't forget the mango tree is falling from the top of a tree. The mango fruit is falling from the top of a tree to the ground, which means my G is going to be positive, right? So which means, excuse me, my G is going to be plus 10 meter per second. So I'm going to be using the downwards equation of motion. So since I'm using the downwards equation of motion, I'll have, which of the formulas am I going to use? I'm going to use S is equals to UT plus half GT squared. So I want to calculate. Let me clean this so that this doesn't. Okay, so I have this. So I use S equals UT plus half GT squared. So firstly, I have to find the value of my U. So I can also use the formula. I have two formulas. P equals to U plus GT. I can use this or this, but then I don't know the value of my U. So the first thing I'll find is the value of my U. The value of my U will be 0 because it's falling, it's free fall. So this will become S is equals to 0 times T plus half. My G is 10 times T squared. So this will become S is equals to 0 plus half times 10 times T squared. So here 2 can cancel out and then this will be 5. Don't forget the value of my S is 20. So this will become 20 is equals to 5 T squared. So what do I do from here? I divide through by 5. 20 divided by 5 is equals to 5 T squared over 5. And I have T squared is equals to 4. So here I find the square root, which becomes T is equals to 2 seconds. And that's it. I use the, not confuse you. I use this formula, this equation, S is equals to UT plus half GT squared. That's because I'm looking for my distance. I'm sorry, I have my distance and I'm looking for my time taken to fall to the ground. So the distance is 20 meters. The initial velocity is going to be 0 because it's free fall. That's 0 times T plus half GT squared. So this is half times my G is 10. Then when I cut this cancel out this, and I have 5T squared. So I have 20 is equals to 5T squared, divide through by 5, and I have T squared is equals to 4, and then T is equals to 2 seconds. So I have my answer there as option D as my answer. So let's take another working example. Just take like 3 examples or so, and then we'll move. You can just go and practice on your own. You get the past question, tpaths. They have the past question, so you just get the past question, and then you can practice working on it on your own. Okay, so example 2 is from UTME 2015, question 38. If a ball is released from a height of 20 meters, how long will it take to reach the ground? Assume G is equals to 10 meter per second. 10 meter, that should be 10 meter per second square. Maybe that's the type of square. So the ball was released from a height of 20 meter. This is very similar to the first question. I'll just do the same thing. T is equals to T is what I'm asked to look for, and then my G is 10 meter per second square. So this is also falling downwards. Okay, so the ball is also moving downwards. That's the direction of the ball is downwards, so which is making this positive. So I'll be using the downwards equation of motion, which is S is equals to UT plus half GT squared. So this will be the formula I'm using. So I'll have S, which is 20 meter, is equals to, since it is free fall, the initial velocity will be 0 times T plus half times my acceleration due to gravity is 10 times T squared. So this can cancel out this, now 5. And this will become 20 is equals to 0 times T is 0, and this will give me 5T squared. And the same thing, divide by 5. And I have T squared is equals to, I have T is equals to 2 seconds. Now this, if you notice this first, the answer to my first question and the answer to my second question is both 2 seconds. Now this brings a rule. All objects falling at the same distance are going to reach the floor at the same time, provided there is no air resistance. Now, what do I mean? If I'm throwing a marker, let me say I have my marker and I have my phone, and I'm throwing it from the same height, right? And I'm throwing it from the same height. They are going to reach the ground at the same time, provided there is no air resistance. So if I have two objects, probably a paper or a feather, whatever, or a ball and a machine or something, anything you call it, as far as I'm throwing them from the same height, and then you remove air resistance, provided there's no air resistance, they're going to reach the ground at the same time, which means the force of gravity is going to act on those two objects and bring them to the ground at the same time. So that's why I have 2 seconds for the ball and 2 seconds for the mango tree. So even if I throw probably a bag or a chair or a sofa or something from that particular height, yeah, it's going to reach the ground at exactly 2 seconds. Remember, provided air resistance is ignored or air resistance is neglected. So you can be asked this question. You can be asked this question as in a multiple choice question in JAM. Okay, maybe probably if two objects are falling from the same height, which will reach the ground faster. Mostly, if you say a feather, most times they can ask you a feather or a ball. Don't be confused. The two are going to reach the ground at the same time, provided air resistance is neglected. Okay, so that's it. Okay, let's just take the two examples. You can be asking you questions if you have questions, or just drop your questions if you ask questions, or if you have any questions to ask. Okay, before that, let's move to the third example. This is from 2015, question 36. Okay, so if a mango tree, sorry, what am I calling this mango tree? If a mango fruit is dropped at the height of 50 meters, how long will it take to reach the ground? Probably you must be able to do this by yourself right now. It should be very easy for you to do. Okay, so this way, the height is 50 meters. Okay, so the height is 50 meters, and then time taken is what I'm looking for. And then my solution due to gravity is 10 meters per second squared. Okay, so with this, I can just do the same thing, and I'll say my S is equals to UT plus half GT squared. And then I'll just replace 50. Definitely my U is going to be 0. Sorry, I think marker is, so this will be half, my G is 10. Okay. This is T squared. So here, T can count, 2 can cancel out 10. That's how many 2 can go in 10. That's 2 here 1, 2 here 5. So I have 50 equals to 5 T squared. Here I can divide through by 5, and I have 10 is equals to T squared. So from here, I'll just say T squared is equals to square root of 10. And I find the square root of 10. So it gives me my answer. I think the square root of 10 should be 3.2 or 3.1 something. When you convert it, you have 3.2. And then the answer is D. Okay, so The thing is, you just get your past question. If you have questions to ask, you can ask them. Maybe before we move to a project. Just want to move to another topic now. That's projectile motion. If you have questions to ask, you can just put them. Any question? Okay, so I think I'll just give you guys 3 minutes to ask questions. If you have questions to ask, I just give you 3 minutes to ask your questions in 3 minutes. Then after 3 minutes, then we'll continue and move to the next topic. Next topic should be projectile motion. So if you have questions, you can just ask them. Okay, if you have questions, you can ask them now. You can. I think it's unmuted. You've been unmuted, so you can ask the questions. You can make it totally. You can raise your hands then to ask questions. If you have any questions to ask, you can ask them now. Or no questions. Okay. I take that as no questions. If you have any question, you can ask them. Or if no questions, then we can move on. All right. Since there's no question, then we'll just move on with projectile motion. I guess you understand them very, like you understand what I thought very clearly. Okay, so we'll move on to projectile motion. Okay, so when we talk about projectile, what's projectile? Projectile is simply the trajectory of an object, the curved trajectory of an object when thrown or projected into air. So you can say it's the movement of an object along a parabolic path, right? Along a parabolic path when projected or thrown into air. So now, for example, if I take a stone and shoot fire it from a catapult or release it from a catapult, yeah, that curved path, you're going to get something like this. When objects are projected and they get this kind of curved pattern or parabolic path in their trajectory, is what we call projectile. So projectile motion is simply the movement of objects along a parabolic path when they are projected into air. So examples of projectile: one, a stone released from a catapult. So if you release a stone from a catapult, it's going to take this kind of parabolic path along its trajectory. So another example is a bullet fired from a gun. So it's going to move from the gun, then it's going to fall. That's um, projectile. And then the movement of a ball into the net when thrown by a basketball player. We also have this parabolic. And another one is movement of table tennis. When you're playing table tennis, the trajectory, sorry, the parabolic trajectory part of the objects of the ball is what we call projectile. Time is time is using we're going to solve velocity. Time is using projectile. Represents initial velocity. Represents initial velocity with you. And initial velocity is the velocity which projectile was through already. Velocity at which the projectile was through. Now, at that moment of projection, the velocity at which the object was released the time of flight. Time of flight is the time taken object to move from point from certain horizontal level to this projected. Now, for example, okay, so for instance, I have something like this. I call this my initial velocity v meter per second. This straight line is my initial velocity v meter per second. So now my time of flight is the time taken for the projectile to move from here to this point. Now to move from its starting point to the same horizontal level, that's to the same horizontal level from which it was projected. So now at the point when it gets to this place, it's called time taken. Sorry, it's called time of flight. So here, when the objects, the time taken for the projectile or for the object to move from here to here is the time of flight. So now here, which is my velocity, is my initial velocity. This angle here, this straight line you see here, measured in meter per second. Of course, time is measured in second. So my velocity is measured in meter per second. So now the next another term used in projectile motion is horizontal range. Now horizontal range is the horizontal distance between the projectile motion. Is the horizontal distance between the projectile projection point to the end of the trajectory on the same horizontal level. That's from here to here. Kind of like from this point to this point. So when I have something like this on the same horizontal level, this is the range or horizontal range of that projectile. So from this point to the point at which it touches the same horizontal level from which it was projected is the range. So now the maximum height is simply the highest vertical height in the trajectory of the projectile. Maximum height is simply the highest height in the trajectory of the projectile. So now we'll be moving to writing the formulas of all of this using the equations of motion. Don't forget, projectile is also a type of motion. So we'll be using the formulas. So now from here, I have this as I'm not going to rub this off, so you can be seeing this somewhere. Now, on our projectile, as you can see, we have the here is called y-axis, and here is called the horizontal axis. That's in our normal, but then in physics we call it horizontal component and vertical component. My vertical component is the y, and my horizontal component is the x. So now here, since this is not the velocity is not on any of the components, it's not on a straight line component. So now it's on another component, it's another z um what do I call it? Um what do you call this thing? Abscissa on itself. So this y component and x component is what we use to get my v. So now, first of all, from the horizontal component of the velocity, we have to find the horizontal component of the velocity, the horizontal component, the vertical component of the velocity, and then the horizontal component of the velocity, then the vertical component, which is the height, and then the horizontal component, which is the range. So how do we get to do all of this? So firstly, I'll say my Vy and then my Vx. Okay, let me make it. Is this okay? I'll just write horizontal and then vertical. So for me, I'm going to draw this out. I'm going to draw out this guy here. You guys should just pay very close attention to this because I'll be deriving the formulas and all the equations of solving all of these parameters in projectile. So here is my v, which is measured in meter per second. That's my initial velocity. Oh, sorry, it should be u. That's a mistake. It should be u. Initial velocity is u. That's capital U. And here is my y component. And here is my x component. So here is my initial velocity. That's the velocity at which the projectile was projected. So now, firstly, I have to find the horizontal component of this initial velocity, which is uy. And then the vertical component of this, why am I mixing this up? Sorry. The vertical component of this initial velocity, which is uy, and then the horizontal component, which is ux. Okay, so yeah, I can complete this by having this. And this will also be uy. Why this will be ux, right? So now, since this is ux and this is uy, so for me to find uy, I can use this SOHCAHTOA. So uy will be equals to, my uy is my opposite, right? And this is my hypotenuse. So I'll say I have my opposite and my hypotenuse. So that should be sine theta. Sine theta is, let me change my color. So sine theta is opposite over adjacent. My opposite is uy, and then my hypotenuse is u. So here, if I cross multiply, I have my uy as u sine theta. That's cross multiplying. I have my horizontal component of the, my vertical component. Sorry, anytime I use uy is vertical component. My vertical component of the initial velocity as uy equals to u sine theta. So now, to get my horizontal component, which is ux, I'm simply going to use, this is ux is my adjacent, and here is my hypotenuse. So I want to look for the hypotenuse. So I use cos. Cos theta is adjacent over hypotenuse, right? Which is ux over u. So I have cos theta is equals to ux over u, which is adjacent over hypotenuse. So from here I can say, let me write this, cos theta equals to ux over u. So now I'll say ux is equals to u cos theta. So my uy is u sine theta, which is the vertical component of my initial velocity, while the horizontal component of my initial velocity is ux, um, ux, which is u cos theta. So I'm just going to write it here. For the horizontal component, ux is equals to u cos theta, and then for the vertical component, uy is equals to u sine theta. So I've done that for you. So now the next thing I want to do is I want to do that of the instantaneous velocity. Instantaneous velocity, I think I've explained it in one of our classes. Instantaneous velocity is the velocity of an object at a particular time. Let's say at 3 seconds, instantaneous velocity is the velocity of that object at 3 seconds. So instantaneous velocity is, I'll use the equation of motion, v is equals to u plus vt. Now, first of all, before I move to that, firstly, um in the horizontal component, as you can see, the horizontal component is moving upwards. That's the vertical component, sorry, is this one straight. That's this y, the one you call y axis. Why the horizontal component is this one you call x axis. Now, acceleration, that's force of gravity, is acting on the y axis, but then it's not acting on the x axis. So now, when this object is moving upwards, as you can see, the my y axis, which is my vertical component, is pointing upwards, which means the acceleration due to gravity is acting downwards on it, and it's going to make my acceleration due to gravity minus g. So now for my horizontal component, my ax will be 0. Why is it 0? Because acceleration of gravity, acceleration due to gravity, which is force of gravity, is not acting on this horizontal component. So now my horizontal component is 0. That's the acceleration due to gravity. For the acceleration for the horizontal component is 0. Now for the vertical component, as you can see, for this vertical component, the acceleration due to gravity is acting downwards. That's, which means the force of gravity and then the direction of the motion of this vertical component, they are opposite. So which means my acceleration in the vertical component, ay, is going to be minus g. So now here I have my horizontal component of the initial velocity as ux is equals to u cos theta. Then the vertical component of the initial velocity as uy equals to u sine theta. Now, for that of the horizontal component of the acceleration, I have my acceleration as 0 meter per second square. Then for that of the vertical, I have it as minus g. So yeah, I'm now moving to the what do I call it? Instantaneous velocity. So the instantaneous velocity for the horizontal component is v equals to u plus at. So don't forget, I can just rewrite this as, for the horizontal, I'll write this as, I'll add x to everything. Vx is equals to ux plus at. Ext, sorry. So I have my Vx, which is the instantaneous velocity of the horizontal component. So now my Ux is what? U cos theta. Don't forget, I already the first equation here, I said ux is equals to u cos theta plus my ax is 0 for the horizontal component. So this will become 0 times t. So which means instantaneous velocity is equals to u cos theta for the horizontal axis. So here is, let me write it out. Initial velocity, acceleration. I hope you guys are following me. And then this is instantaneous velocity. Instantaneous velocity. Okay, so for the instantaneous velocity, I have that of the horizontal component as u cos theta. So ux is equals to u cos theta. Now for the vertical component, I'm also going to do that. I have v is equals to u plus 80. So instead of writing this, I'm just going to summarize all of this into the vertical components. How do I do that? Vy is equals to uy plus ayt. So now my vy will be equals to, what's the value of my uy? My uy is u sine theta, right? So u sine theta, okay, so let me come back. This u vy is equals to uy plus ayt. So now my vy equals to, my uy is what? U sine theta plus ay. My ay is minus g, then minus g times t. So this will become vy is equal to u sine theta minus gt. All right. So which means my instantaneous velocity for the vertical component is vy is equals to u sine theta minus gt. Don't worry, we are getting to where we'll be using all of these formulas. Just follow me. It's all your attention. Just, and we have this. Now the next thing is, I want to check the time taken to reach the maximum height. So time taken to reach the maximum height. So the time taken to reach the maximum height is the time taken for the projectile to move from this point to this point. That's the maximum height is this ish. So time taken to reach the maximum height. Yeah. So the time taken to reach the maximum height. Now, if you can notice this, you can see in my time taken to reach the maximum height, I don't have any business to do with my horizontal component. Why? Is because the time taken to reach the maximum height is the time taken for the projectile to move from this point to this point, which means the only increase is the increase in h. So what I'm going to do here is I'm going to use the formula v equals to u plus et. And then I can just say v minus u is equals to at. And I say t is equals to v minus u over t. I can just do something like this. But then instead of writing all of this, I'll just rewrite it in the horizontal component. Vy is equals to u sine theta minus gt. Now, when I'm writing this, u sine theta minus gt. Now, at this point, when the projectile is at its maximum height, the velocity is zero. The instantaneous velocity is zero. Why? Because the acceleration due to gravity has acted or has negated the velocity, the initial velocity with which the projectile was projected, and it has negated it to zero. So at that point, the acceleration due to gravity is now changing from minus, which is making it to go up, and it's changing to plus, which is now making it fall back downwards. So now it's going up before the acceleration due to gravity is acting on it is negative. And then when it gets to this point, the instantaneous velocity becomes zero. And then acceleration due to gravity changes from negative to positive. And then the object starts moving downwards. Are you with me? So now, at this point where the object is at its maximum height, the instantaneous velocity is zero because the acceleration due to gravity has acted against the initial velocity and it has brought the velocity to zero. So which means here I'll have zero is equals to zero is equals to u sine theta minus gt. So here I can just bring this minus to this side to have a positive value. So I have, when I'm bringing this minus gt to this side, to become plus. So this becomes gt is equals to u sine theta. So now I'm looking for t, right? So I can just divide 2 by t. Sorry, divide 2 by g, and I have t is equals to u sine theta over g. Now that's the time taken to reach the maximum height. The time taken for these objects to move from here to here. So the time taken to reach the maximum height, the small letter t is equals to u sine theta over g, where my u is my initial velocity, theta is the angle of projection, pi g is the acceleration due to gravity. So that's the time taken to reach the maximum height. Now, moving forward, we move to the horizontal range. Now, the horizontal range is dealing with the horizontal component. The horizontal range is dealing with the horizontal component, which is okay. Sorry, I forgot to do the distance, total distance traveled by the object when I was doing this horizontal and vertical component. Okay, let's quickly do that. Total distance traveled. So for the horizontal component, total distance traveled, I'll be using s is equals to ut plus half at squared because s is distance, right? So I'll be using s is equals to ut plus half at squared. So now for my horizontal component, my x will be equals to uxt plus half ax t squared. Now I'm resolving this into the horizontal component. So I'll say x is equals to ux. My ux is what? U cos theta. U cos theta t plus half ax. All I know is my ax is 0. So when I multiply all of this, it's going to give me 0. So my horizontal component, that's the distance traveled in the horizontal component is x is equals to u cos theta t. Now for my vertical component, so this will be y equals to uy t plus half uy t squared. Are you guys seeing this? So now this will become y is equals to my ui is u sine theta t, u sine theta, then times t plus half my ay will be minus g, then times t squared. So here I have my y to be equals to u sine theta. So this will become minus half gt squared. As this minus is multiplying this positive sign. So this is becoming minus half gt squared. So now the horizontal distance, oh sorry, the distance traveled for my vertical component is y equals to u sine theta minus half gt squared. Y for my horizontal component is u cos theta t. I'm sorry, I didn't add t here. That's t for me. So this is u sine theta t minus half gt squared, and then u cos theta t. Okay, so I'm going to add this down. I'm going to write it down somewhere. Okay, let me just leave it wait. Distance traveled. So for the horizontal component, it's going to be u cos theta t. While on the vertical component, it's going to be u sine theta t minus half. So this is the distance traveled on the horizontal and distance traveled on the vertical component. So now I'm going to find my range. I hope you guys are still following me. Because needing most of these things when they give you. Continue with this.